Hi, this is Mr. Mitchell. We'd like to talk about three kinds of boundaries of tectonic plates: divergent boundaries, convergent boundaries, and transform boundaries. As you can see on the screen, I like to talk about divergent boundaries first. Now, one way you can remember divergent boundaries is because of the prefix. The prefix is di, and you might can think of the word divide. Because these two boundaries divide, they separate. One plate goes one way and one plate goes the other way. Now, we've already mentioned a little bit about these whenever we talked about mid-ocean ridges. Now, these mid-ocean ridges up here, I'm not drawing very well today, but these mid-ocean ridges here have these two plates that are indeed dividing. And what's happening is you have the magma which is coming up and it's pushing the plates away, and these plates are dividing. This would be divergent boundaries. So underwater they're called mid-ocean ridges. Above the water they're called rift valleys. And you can see down here we have rift valleys. Oh, I'm just awful with the markers today. But anyway, on this rift valley here, you can see where the edges are. Right here and right here, these two tectonic plates are dividing. They're going in opposite directions. Now, sure, you have magma, which is going to be coming up in here, and I think we may have even mentioned that in class. Now, it's not bubbling up. It does seem to form new land, but you would be closer to the magma in this little divide area here than you would normally be. So you have mid-ocean ridges underwater, rift valleys above the water. And I think our book is also going to call the underwater spreading centers. So if you happen to see that, that's what they're talking about, those mid-ocean ridges. So it is magma that comes up in the gap whenever you have these divergent boundaries. When magma hits the cooler water or air, it forms rock. And that is why you have the younger rock, which is going to be closer to the ridges. The younger rock closer to the ridges. The older rock will be a little bit away from the ridges. I do want to mention a couple of things. We have rift valleys that often have a lake or water in them. And you can imagine if you have a rift valley where one side's going one direction and the other side's going another, this place in the middle could drop below sea level. And as a result, any nearby water would, well, it'd fill the gap right there. And that's exactly what has happened here. This is Africa, the continent of Africa on the left here. And this is the continent of Asia up here. And what has happened, this area right here is the Red Sea. And scientists believe that this is one great big rift valley that has been filled in with water, that these two plates are going in opposite direction. And since it got below sea level, then you had the water coming from the oceans to fill it up. Let me talk about something called hot spots. Hot spots are in the middle of a plate, and these usually occur away from the plate boundaries. If you have like a candle underneath paper, if you have a candle underneath paper, you can imagine what would happen to the paper. The paper would end up burning in the middle. Just think if you have kind of the same setup, you have magma that's underneath these plates. It's going to kind of burn into the rock. So what happens is it reaches the top here, the magma cools and forms rock. The magma cools again and forms rock. The magma cools again and forms rock. The magma cools again and forms rock. And before you know it, you have a volcano there. So these hot spots is actually what people think formed Hawaii. Down here you have a picture of Hawaii, and that this island is a hot spot and this island is a hot spot, and all down through here the islands are hot spots. Now you might say, is that different hot spots? No, it's the same hot spot. The hot spot's not moving. It's fixed. It's the plates that are moving. So what happened here, it's a pretty good picture right here. You have this hot spot that was formed, or this volcano that was formed by this hot spot. The plate had just moved. And then later on down the line, another volcano had formed from the same hot spot. Another volcano had formed from the same hot spot. And you can see this volcano formed from the hot spot more recently. So that's a little bit about hot spots there. And one thing that the hot spots help scientists know is how quickly these tectonic plates are moving. I know we mentioned that the North American plate is moving about 1 inch per year. I mean, they can have a little bit better idea by seeing the distance between these hot spots and how old they think these rocks are. Okay, I want to talk about one of the other kind of boundaries. I want to talk about convergent boundaries. I'll put this one in black. Convergent boundaries here are ones that push together. They are the plates that push together. Now you probably have an idea of what happens whenever you have plates that push together. The crust is either going to be folding or it will be destroyed. I guess the folding, let's talk about it first. When you have the plates that push together, it's going to kind of bend up a little bit. These are ones that have the same density, and these are the kind that form mountains. And that's what happens whenever you have plates of the same density. But when you don't have plates of the same density, you have what's going on right here. The ocean plates are supposed to be more dense than the land plate. So here when you have this land plate coming up against this ocean plate, the ocean plate will buckle under because it is more dense. It is heavier. So the more dense is going to buckle under, and that process is called subduction. Whenever you have a plate buckle up under another plate, it is called subduction. What happens here, it forms these deep trenches in this subduction zone. This is going to be a deep trench, and it also forms volcanoes on the other side. Now you see what's happening here. You have all this magma which is coming up, and these plates here is going to go down into the mantle, and these plates are going to be destroyed because the mantle is going to be 900 degrees, maybe even more. Destroys all that rock. But in the destroying of all that rock, you tend to get the formation of volcanoes just a little off the coast. And this is a picture of what happens. This is Canada and the United States here. You have Mount St. Helens, which is in the United States. You have Mount Hood, which is in the United States also. And they apparently form from this subduction zone. The plate goes under, and you have magma which tends to form volcanoes just a little bit off the coastline. And that happens all around the subduction zone of the Pacific. Ocean plates meeting ocean plates. Well, what will happen is that the older ocean plates will end up subducting over under the I'll say that again. The older plates usually subduct under the newer plates. So if you happen to have these plates under the ocean, you still have the same kind of subduction action, but it's just going to have one plate will be more dense and older than the other. When, of course, they will end up forming some volcanoes that stick up out of the water. There is a big trench called the Mariana Trench, which is formed from a subduction zone over near Japan. And the Philippines are islands that come from an underwater subduction zone. You have two plates that are hitting here, and you have one plate subducting, and it has these volcanic islands which form as a result. So that's how the Philippines happened. Okay, we also have transform boundaries. Now transform boundaries, well, the divergent boundaries went away from each other. The convergent boundaries went toward each other. The transform boundaries are going to go in opposite directions and scrape each other. And we have a good example of a transform boundary in the United States. We have this whole area from here over, which is the North American plate. It actually follows all the way over through Georgia. This is the same plate that we're on. Please pardon my awful writing here. But this is the North American plate. And this part of California, the southern part of California, is actually on a different plate. We have this plate which is going this way, and this plate which is going this way. So as a result, you're going to have the plates moving, and you have lots and lots of earthquakes anytime you have a transform boundary. And yes, you have lots of earthquakes going up and down this line right here.